Hey there, sixes. I'm going to try to make this super quick. 9 people turned in work this morning, and the vast majority of all the work you guys turned in was awesome. So I just wanted to point out the couple things that could be issues, or the couple things that I see, which really come down to, in this case, I want to talk about justification. All 3 of these students got question 4 correct, but some of them could have justified their answers better. And by justifying, I mean like explain, how did you know that they were correct? They could have done it better. So let's look through what they were saying. During which 5-year period does debt gain the least weight? Well, so like he's gaining weight everywhere here. When is he gaining the least? So the smallest amount of weight. Well, this student said between 5 and 10 years, because they can see how the graph rises, and when it rises, not so much. So I see that. This student is looking at here, they're breaking it off at like, maybe I'll try to color code these. We'll do this one in blue. So this person is looking from 0 to 5, from 5 to 10, and from 10 to 15, and simply saying between those, which one was rise not so much? And they said from 5 to 10, like this is the section, they see it rising not so much. I get that. That's not a bad description. I understand what they're saying. It's fine. So during which 5-year period does he gain the least weight according to this student? Same one, 5 to 10, but they knew it by the graph in 5 to 10 is a more flat line. So I'll use red because they already used red for some of it. So they're really looking at, if I make that a line, if I make this a line, and if I make this a line, that this one is the flattest. So that makes sense. I can see why they would choose that. I'll say flat. And I really mean like it's the flattest. It's not totally flat, but it's flatter than this, and it's way flatter than this one. So that makes sense. And here's the third person. I'll do purple for this person. So this person said 5 to 10 is the correct answer. Great, I agree. So did these people. For 0 to 5, he gained 40 pounds. So there's where he was at 0. Here's where he is at 5. And when they look at those values, they're saying he gained 40 pounds. Now, he started at like 8 or 9 pounds. So I would actually argue he gained a little less than 40, but it's fine. It's this maybe should be a 30 or something like that, but no big deal. I see that from 0 to 5, he gained about that. Fine. From 10 to 15, he gained more than 80 pounds. So at 10, he was here. He's looking at starting there, going up to 15. He's way up there. He gained a whole ton of weight in there because I can see all that space. So then he's really just looking at this space, and this one, and saying this space is the smallest because it's 20 pounds. So between the 3 of those, there are 2 things I would point out. This person has a decent description, but it's a decent description in very rudimentary English. Like there's not really any quality vocab. There's for a 6th grader, I would say like the English level is pretty low, but the math is good. The description here is solid, just not as well justified maybe as if we're here. The only real difference here is this person's talking about a flat line. But that's a very mathematical idea, being able to take this curve, because it's a curve all the way through, and make it into a linear type of thing, compare those 3. Well, that's a mathematical process. So I actually like this considerably better. And I actually like this one the best because he's the most specific. From 0 to 5, he gained this much. 10 to 15, he gained this much. 5 to 10, he gained this much. Therefore, I know 5 to 10 is the best. That's fine. I totally see that. And I mean the best answer to this question. So more specifics in math is usually more useful. Also, using better vocab, it defines your response better. It gives better justification that we all understand. And this is fine. I don't mean to trash on it at all. It's a good description. I'm just saying that we could do better. That's all. Here's the other question I wanted to talk about. It was Martha. It was the last question on the whole thing. So Martha Ways, I was going to color code these. Let's say this one is purple. Let's do this one is blue. And we'll do this one is red, but I'm actually going to split it. So I'll do this one, let's say red and orange, because I'm going to say red is from 9 to 13, and orange is going to be else, like everywhere else. And that's really because it says only between, which gives us like kind of this second orange condition. So I think pretty much everyone, and not pretty much, everyone that I saw nailed this first condition, where they looked at that and they said, From 0 to 4, they weigh the same. We want that thing to match up exactly. Great, that's awesome. Then most people knew exactly where to go with this too, which is awesome. At 13, Martha weighs 20 pounds more than Derek, Dec. So at 13 years, I'm going to go up here, and I mean like at 13 years, that's Dec is at 110. So Martha should be at 130, which is 20 more. Good. So now we have this point, and that's the only thing this blue part gives us, that second condition, is that point that we have to go through. That's it. So then the last piece is between 9 and 13, only between 9 and 13, does Martha gain more weight? Well, that means between 9 and 13, however fast Derek is gaining weight, if that's Derek, Martha's got to be gaining faster. But it also says only between 9 and 13. So everywhere else, we've got to have however much Martha is gaining, Derek is gaining weight faster everywhere else. So between 9 and 13, I want to make sure I do this thing where Martha grows faster. So at 9, I'm just going to start in an easy place to start, which is way below Derek. If I start below Derek and then I make sure she grows faster at every point, that's fine. I connect it up to where I need to go. She's growing faster at every point. And then lastly, I want her to grow slower here and slower out here. So you can do kind of whatever you want, as long as it's growing slower than Dec's graph is. Now these are really close, but I would argue this is slower than this. Yeah, good. It obviously is on average, because by the end, this Dec's line is higher than Martha's, so it has been on average. So those were the things I was looking for. In general, when I saw it, you guys are doing really well. The last thing was vending machines is going to be the next activity I'm going to give you guys today. So when you guys see vending machines, I just want to make sure you know what they are, which means I should have pulled up a picture. Vending machine. So vending machines just sell candy and soda pop usually. The one it said we're looking at sells soda pop, so it's going to be like this, where it's full of soda pops, punch in your numbers, and the soda pop drops out. That's it. So if I look at this, that's why this thing doesn't have a nice curve to it at all. It's because there were 6 sodas, and then someone bought one. Now there's 5. There's no curve between there. It just instantaneously happens that it dropped from 6 to 5, and now the machine has 5. And then when someone drops it or buys one, it drops to 4, and then 3, fine. The last thing I note is what's happening here. This is like, we started out with 24 sodas and people are buying them like crazy. This vending machine is running out of soda, and then the guy comes in and restocks it. So now it's full again, and then it keeps going. Monday ends at 17, so you can see Tuesday starts at 17 and then continues. I just want you guys filling in questions here, showing me what you know about coordinates. That's all I've got. Best of luck, 6s. Go for it.